where
Right.
things are. Yeah.
So how long?
How long?
How long before we can start sending human beings to Alpha Centauri?
To Alpha Centauri.
Yeah.
Okay, well, that's going to be a little longer because we have to open wormholes and
Right. So wormholes, that's a whole other can of worms.
yeah, exactly, definitely, and a whole other kind of worms, and it's but the physics are there. I just want to make clear that when I'm talking about wormholes, you know, this is predicted by Einstein field equation. It's well supported by observation, meaning that like Einstein field equation in the form, in their classical form, are very well supported. But it was until recently thought that it's not possible to open any of those wormholes and travel through them because the energy requirement to do so were just over the top. Now that we have discovered that there's this field of information, this field of energy,
Zero-point energy.
present, and that the density of that field is so high, now the physics works out that absolutely you can open wormholes if you can tap into that field of energy. And that's why people like Sonny White at NASA and others are literally working on warp drives as we speak today.
Right. That's astonishing to think.
They can see in the physics and in the math that there's a path to getting there.
So NASA is working on warp drives.
Absolutely.
And a warp drive would simply be the ability to open a wormhole, to jump across space without being limited by the speed of light,
Correct.
and using anti-gravity.
Yeah, using gravity control. And that, you know, will take probably, you know, a while before we have the expertise to be able to safely reconstruct you on the other side of that wormhole, you know, so that all your molecules end up at the right place at the right moment.
So it's like teleportation.
Yes.
So you mean when you go into a wormhole, you're disappearing? Is that what's going on?
Well, you can think of it, and this is where standard theory doesn't quite cut it to describe what's happening, and this is the new theory that is emerging, is basically all the particles in the universe are entangled. And that's emerging. There's a theory by one of the greatest theorists on the planet that's called ER equals EPR. And this is from Sutskin and others, Montesino and others, that show that you can write physics in such a way that that entangled particles, which we measure in laboratory. So does everybody know what entanglement is? Right? So you can get two particles to be entangled in such a way that when you tickle this one, the other one laughs. And it doesn't matter how far the other one is. It gets the joke. Like you tell it to this one and the other one's laughing. And it's like...
And it means if you change the spin of a proton over here, this spin of the proton will align itself.
That's right.
No matter how far.
No matter how far they are. And they're starting to be able to do it with macro objects like diamonds. Right. So that you hit this diamond with a laser and the other one is wiggling like you're hitting it with the laser. And so basically, and there's no delay. That is, it doesn't matter how far the particles are. It's instantaneous. When you modify this one, the other one is modified.
Now, if that's instantaneous, then information there is traveling faster than the speed of light.
Well, this is why quantum theory and relativity don't agree so well. But that's the beauty of this view that's emerging that came, you know, I came to the same conclusion from a different angle. ER equals EPR. ER is for Rosen bridges, Einstein-Rosen, right, ER, which is the wormhole, equals EPR, which is Einstein-Podolsky-Rosen, which is entanglement at the quantum level. So it's saying that the reason particles become entangled is because wormholes form between them, which is basically relativity applied at the quantum level. You see, so that's where unification of physics.
So entanglement, particle entanglement, is
Yes.
an evidence for Micro wormholes.
Micro wormholes, connecting things. And so basically, what we're gonna do when we're traveling through wormholes is basically we're gonna make, since everything is entangled, and that is coming out in these equations as well, that we're gonna make the information of you and the ship and everything in the ship, the whole universe. Well, we're going to throw it into the wormhole, black hole structure network of the universe and reconstruct it on the other side. On, you know, it might be a galaxy thousands and thousands of billions of light years away from here.
So then, is that traveling through a wormhole or is that teleportation? What is the difference?
Well, yeah, you can think of it as teleportation. But in reality, I mean, it depends how you think of teleportation. And the reason I'm hesitating is because there's very specific, precise language in physics that describe teleportation, and I'm trying to like say it in a more layman way. But let's just say that basically I'm deconstructing all the information that you are and reconstructing it on the other side after it has gone through the network of the universe, right?
But if that's true, then you're deconstructing someone and bringing them back. Can you deconstruct someone, back them up, so when they die, you can recreate them? Can we bring people? Can we then bring people back from the dead? Like, could I have backup copies of my favorite dog?
You already do, but because the information is in the structure of space.
And if Hayden disappoints me as an adult, could I just, you know, like, recreate a 10-year-old?
Oh, that's a whole other story.
Yeah.
Because he might be not so agreeable to
Hayden,
that idea.
I'm just kidding.
Yes, but my 12-year-old is already not so agreeable with some of my ideas. But you can imagine that, yes, I mean, what I'm saying is that what you are is information in the structure of space, and you're constantly updating the universe. Every Planck second, you're actually updating the universe about your experience. And so you can think of yourself as actually like, you know, being here and not being here, being here and not being here. So let me put it in more simple terms. Let's, I'm going to give you an example. I hope it won't take too long. I'm going to try to make it short. I have, you know, you're trying to do a simple physics calculation, right? You would think you can do in high school.
Right.
You want to know how fast your hand is going from A to B. Simple, clear, you know, you start at A, it goes to B, you figure out how long it took to get there, and you can output the velocity at which it had to travel to go from A to B. Is that true? No. If you're trying to do real physics, if you're trying to actually be completely honest about what you're trying to measure, you have a huge problem. Because as your hand went from A to B, the Earth was spinning. And so you have to add that velocity to your hand moving, and it's spinning pretty fast. And then that's going around the sun, right? The Earth is going around. So now you have to add that velocity, because while your hand was moving, it did move in that direction with the Earth and around the sun, right? So you have to add that. And then the sun is going at 300 kilometers per second in the galaxy. So now you have to add that. And then the galaxy is orbiting, and then around the cluster, the super, and like, whoa, your hand is going millions of miles per second now. Right? And so, and eventually, if you keep adding that, eventually you get to the speed of light. So like, what is going on? What is your hand doing? Well, it's only moving at that velocity you calculated in high school relative to you. But relative to the universe, what is the universe doing when it's moving then? What is movement? What is that, right? Well, the only conclusion you can come to is that your hand is undoing itself, redoing itself, undoing itself, redoing itself. So it's your hand is your hand, and then it's the whole, and then it's your hand, and then it's the whole, and then it's your hand, then it's the whole. And it's happening at frames of Planck time, so it's happening really, really fast. Just like a movie is frames that appears to produce linear motion, but is actually frames, that are being passed by a light at speed high enough that you don't see the discontinuity.
So, from that point of view, our bodies are deconstructing and reconstructing itself at Planck's second intervals across the universe, across millions of miles.
Yeah, imagine that concept. Like, imagine that's occurring at the Planck scale, right? Very, very, very fast. And then imagine the dampening of that same undoing and redoing itself happening at a much larger scale, like biology. You're doing that right now. Fission, like a month ago, is not the same guy. Like, you've redone your liver, you've redone your blood a whole bunch of times, you've redone your skin. And within 3 years, you've pretty well redone the whole thing. Right? So you're actually redoing and undoing and redoing yourself like every second as well.
Which opens up this question. And this is the final question. This is from one of our viewers on Facebook.
I just want to finish the analogy. So now you can imagine, if I get this undoing, redoing thing, first of all, I can redo myself a little different if I want to be different. But I can undo my hand there and redo it there without doing all the points in between. See? Space travel across the universe.
Mind blown. So